Get ready for your desert adventure. You're a geologist with the British Geological Survey, and you've been dispatched to map an entire country in the Middle East. Your tools include a shovel, a rock hammer, a battle-hardened laptop with GPS, an emergency rescue rope. Get in your 4x4 vehicle now. The country is the United Arab Emirates, where days can be boiling, nights can be freezing, and 80% of the land is covered with sand. Each morning at a villa in Abu Dhabi, the real British Geological Survey team decides what to map, what not to map, and who will do the mapping.
John is doing this area here, and that area just there is your bit, my bit. Everything north of that pipeline has been completed. We need still to get permission to go into this security area around this oil field, so that's still outstanding.
Richard Ellison is the team leader. He's been with the BGS for over 30 years.
That's the one that we did together, you remember?
Yeah.
Bob Thomas has been on the mapping project since it began in 2002. In addition to security concerns, there's plenty of hazardous terrain to navigate.
This is an area that's been a bit tricky in the past.
Yeah.
I've got a few gaps to fill in around here, and then that's the traverse that we finished yesterday.
Helen Burke is the newest member of the team. It's her first international assignment.
It's fine white sand and it's really easy to get stuck in there.
Each point on the map represents a geological data entry, and when the process is complete, the team will have made about 30,000 entries, and there are thousands of entries still to make. Bob will be heading for the dunes. Helen will be heading for the mega dunes. And Richard will be heading for the coastal areas.
The fog's unusual. It's unusually late in clearing. It's normally cleared by about 8:30.
So do you see what I mean about the dunes on dunes? You've got the massive dune forming a big ridge, and you've got all these smaller ones riding up on the edge.
There are many do's and don'ts about driving in the dunes. Rule number 1, let some air out of your tyres to increase surface contact.
Here we go. Yeah, I'm going to have to do, I think I want to go to four-wheel drive. Oh, hold on tight. It's going to get a bit bumpy, I'm afraid. This is the Liwa Desert where we are now, which is where the biggest dunes in the country are. In the flat areas in between them, you can get sabkha areas forming, and you get salt pans crystallising out that's covered in gypsum, a flat-lying area where the water table is actually not very far below the surface. We're making a note of the edge of the sabkha area and where that meets these dune ridges.
The sabkha are salt flats that can be found in patches between the dunes. Sabkhas also exist in vast areas along the coast of the Emirates.
Any developed and developing country needs to know what's beneath its feet. They need to know the distribution of mineral resources. They need to know the types of ground conditions that exist, which assists in development projects, infrastructure projects, that kind of thing. We're here to map the extent of the sabkha. But of course, more important is to try and understand how the sabkha forms. These rocks here have been dated. They've been dated by radiocarbon dating techniques. And this sequence from here, approximately to here, is said to be approximately 4,000 years old. So this is 4,000, this was maybe 10 years. So that gives you an idea of the scale of, or the rate of deposition. underneath here there's something very different, and you can see the colour's different, and it's actually harder, it's more cemented, it's cemented by carbonate rather than gypsum, and it's full of shells. Some fossil shells in here. These sediments under here are dated to be about 8,000 years old. So we have to then build up a story. What are these doing here in relation to these? And the answer is that these rocks were deposited as the sea level was rising. In other words, this is what we know as a transgressive event. So the sea level was rising and marine sediments flooded in across this area. The sea then retreated, and as the sea retreated, the Sabkhas developed. And that's the simple story.
What we're doing here is we've got a series of very fine grey sandstones here, which is forming the top of this little plain area that we have, and we have to try and see what's underneath. At the top of this little excavation we've got this grey sandstone. Here it is outcropping up here, and the base of it is falling around here. This stuff is that sandstone, and below it you can see the bedding planes in this sandstone outlined by grey and orange layers. This is the Aeolian sandstone. Aeolian means derived by the wind, so all these dunes that we see around us, they're all Aeolian deposits, whereas this sandstone is what we call a fluvial deposit. It was deposited by water action. This is the point that we are now in this position amongst all these sand dunes. So that is where I made my observation point, and then as I make the point I get this screen, which is where all the various information is added onto the computer. There's a screen here where I write Arada formation, which is the main, which is the formation that we're looking at.
In addition to GPS and satellite imagery, the laptop holds a diary of all geological observations.
And we have this screen here, which is comments, which is where I add the general description of the locality that we're engaged in.
The UAE isn't all sand dunes. There's a mountainous region in the northeast, which the BGS team has spent many months mapping. This region has also been the focus of aerial sensor surveying for the BGS. Radiometric aerial maps can help identify things like uranium. Magnetic aerial maps can help locate things like iron ore. Earth crust formations called orpheolite, which have been thrust to the surface in this region, are the focus of special attention.
One aspect of our current project is to just assess the ophiolite rocks to see if there is any potential at all for platinum group elements, which are rare elements, only occur in parts per billion. So it's a first pass project, really. Sabkhas are really important environments geologically. They occur at various times in the geological column. And one of the aspects of Sabkhas that we're looking at is the development of algal mats. Do you see these orange layers here? This is an algal layer. Actually, if you were to trace them, you could trace them right out to where they're actually at the surface, where they're black and they look completely different. And that's where the tide comes in on a regular basis, and that's where you start to get the algae, okay? So it might seem insignificant here, but when there's a situation where there's numerous algal layers deposited, this is a source for oil. When the rocks are buried and the oil is generated, it's the algal layers which are one of the sources of oil. If we can identify this kind of environment in rock cores, which are drilled for oil exploration, then we can make the analogy and we can start to predict where oil might have formed and therefore where it might have migrated to form reservoirs. Most people would say that the mega fields, the giant fields, have probably all been discovered, but you never know.
It's a mapping setback for Bob. One of the deflated tyres came off its rim in very soft sand. Time for a tow with the emergency rope.
What I'm doing here, I'm just digging a shallow section through this sabkha. This fantastic wrinkled dark surface is a living algal mat. Absolutely fantastic. And so if I put my fingers under it like this, we can get the whole mat to come away. It's like a piece of leather. It's fantastic. And it's only 2 or 3 millimeters thick here. And you can see that underneath the algal mat is this soft, mushy mass, and it's just a mass of gypsum crystals, tiny gypsum crystals. This is very, very characteristic of an active sabkha in the intertidal zone, which is really where we are. If the sea continues to rise slowly, successive layers of algal mats will be deposited in this fashion, and with geological time passing, those will be more deeply buried, and they ultimately will release oil.
After visiting every nook and cranny of the country, the BGS team will produce a series of 45 detailed geological maps in Technicolor.
This is a map of actually the coast, the Arabian Gulf along here exposed in the coast, and then heading further inland this way. And this is the generalised vertical section that you get on every geological map. It's a bit like a theoretical borehole, if you like. It's representing everything that you'll find in this geological map.
This colour-coded column covers 200 million years of geological history.
We've also got a thrust belt zone here, so which is everything's been thrust over towards the west in kind of this direction.
If you're planning to build something in the UAE, a geological map would be the first thing you'd look at. And there's been more building in the UAE recently than at any time in the past 200 million years. And the higher you go, the more you need to know what's below, especially if it's the tallest building in the world.
We knew we had a very tall, heavy building to put on the ground. We had to make sure that the capacity of the ground was sufficient with the foundation to take the loading imposed. There was potential for cyclic degradation and also low bearing capacity. Geological maps is the first thing you'd look for just to get an overall idea of what to expect below the ground.